So, if you wanted to identify an aircraft or something that was in the air based on its ability to be identified, you would have to find its trailer, its contour. Yet, what if you used a magnetic resonance laser imaging device in order to shoot out a high-intensity laser beam on a wide array spectrum in order to interact with the metal components of anything coming at you far enough away so that way when it interacts, you're also scanning right behind it for the interaction of it. So, say you've got a missile, right, coming at you, and you can't see it, yet you know it's coming. So you scan ahead with a wide image array laser that is magnetic, that causes vibration when the magnetic laser hits metal itself, and that vibration itself, when it hits that metal, is not designed to do anything other than resonate with the metal so that the specific spectrum of that laser wavelength is then read by a secondary laser spectrum that when it hits that vibrational spectrum created by the previous laser, it reflects it back. And because of the distance of it to itself and the speed of the laser to it in itself, the vibrational accuracy of it will allow it to be pinpointed. And because it's a continuous vibration, it will also be able to tell where the signature is going because it will be able to get a constant signature of the vibrational mass of the item. So the larger the item, the more vibrational mass it has. It doesn't necessarily work with things like aluminum or high-tech metals that are fabricated or created, man-made, yet it would work with anything that has metalloid signature. And as we know, magnetic frequency can affect almost any metallic that's out there. It doesn't have to necessarily be iron, although Fe1 is important for magnetic resonance. Everything has a resonance factor to itself. So, I mean, it'd be a good way to create a radar signature system that would identify something at a long distance and yet still identify its flight pattern and plan. And you could do it from space. So instead of having it be earthbound up, have it be spacebound down, and have the satellite just do it in a empirical way. That's just kind of like a satellite at the Earth that's constantly scanning down like this. So it's a broad array on a wide spectrum. And then you work it in tandem with a satellite. So one satellite here, and then another satellite here. So that way everything that comes off this side here, this satellite detects it through this way, and everything off this side here comes off of this satellite here. So while the spectrum's going down, these two satellites are looking for the spectrum array coming back. And then in between them run a whole bunch of light-enhanced solar panels in order to be able to have a system on it that has enough energy to run it. Because it's going to take a lot of energy to run lasers like that. Or possibly a nuclear power plant. Either way, it doesn't matter. It would work. It would help for things like hypersonic missiles, because you'd be able to identify what was moving where, what, when, and why, because you're constantly scanning down. And because the signature is just magnetic, it wouldn't affect anything, harming people. Just gives a tuning fork.